Hello, this is checkpoint 4.24. They want us to calculate dz du and dz dv, the partials, for the given function. F of xy is equal to 2x minus y divided by x plus 3y, and then our x function is a function of u and v, e to the 2u cosine 3v. Y also is a function of u and v, e to the 2u sine 3v. These are compositions. We want derivatives of composition, so we will need the chain rule. And the chain rule will be useful to have a tree involved. And our tree will have f on top as a function of x and y. X is a function of u and v, and y is a function of u and v. And so to get these derivatives, we would follow paths from the z or the f down to the u or the v. So our first path would be the partial of f with respect to x. And we want to go to the partial of x with respect to u. And that is going to be our first path going down. And then we want the partial of f with respect to, this is x, partial of f with respect to y, and partial of y with respect to u. So that, for starters, will be our first derivative that we're going to find. And then we're going to get our second dz dv derivative going from the partial of f with respect to x and then the partial of x with respect to v. So let's label this partial of x with respect to v, and then we want the partial of f with respect to y, partial of y with respect to v. And that will be our second path going down. All right, so we're going to need to find some partial derivatives. Let's find the partial of f with respect to x first. That is going to be the derivative of a quotient. So that's going to be low d high with respect to x minus high d low, again with respect to x, divided by low squared. I think it might be worth simplifying this. We have a 2x, negative 2x, so that's a 0 times x, so the x's are gone. We have 3 times 2 is 6y minus minus, so that's plus 1y. We get 7y divided by x plus 3y quantity squared. That's going to be the derivative with respect to x. Now we want the derivative with respect to y. And that is going to be similarly the quotient rule, low d high with respect to y. Now the first term is going to be negative 1 minus high d low, and the derivative of the denominator with respect to y is 3, all divided by x plus 3y squared. Again, simplifying, we get a negative 1 times x minus 6x, so that's a negative 7x. And we have a negative 3x minus minus 3, so that's a plus 3, or that's negative 3y plus 3y, so the y's are gone. And we just have negative 7x divided by x plus 3y quantity squared. Okay, now let's work with the lower half of our tree and find derivatives of x and y with respect to u and v. And our first one, partial of f with respect to u, will equal to the derivative of this function with respect to u. So it's 2e to the 2u cosine 3v is constant with respect to u, so that just remains as is. Next, we want to find the partial of x with respect to v. And this time the cosine 3v is the function. The derivative of cosine is negative sine with an extra 3 that comes out. And e to the 2u is constant. So our dx dv is negative 3 e to the 2u sine 3v. Now let's move to the y function. Let's take the derivative of y with respect to u. And take the derivative of y with respect to v. Now we have our terms. We just need to put them together. Let's take the derivative of z with respect to u, dz du. So that's going to be the partial of f with respect to x times the partial of f with respect, or partial of x with respect to u. That's that first path that we establish. And then we want the partial of f with respect to y and the partial of y with respect to u. Okay, let's get those pieces together. We have the partial of f with respect to x. That's 7y divided by x plus 3y quantity squared times the derivative of x with respect to u. And that would be times 2e to the 2u cosine 3v. And then now we'll add on the partial of f with respect to y. Times the partial of y with respect to u. Now this looks like it can fall under one big denominator, and we normally would want to change everything back to the bottommost variables. That would be the u's and v's. So we're going to take x's and y's and replace it with the functions. First we'll have 7 times y. Y was e to the 2u sine 3v. And then we'll tack on the 2 times e to the 2u cosine 3v. And then we have a minus 7 times x, which is equal to e to the 2u cosine 3v. And then we just have this other 2e to the 2u sine 3v. And the denominator is going to be a e to the 2u cosine 3v minus 3 times e to the 2u sine 3v quantity squared. Okay, now if we take a look at this is a negative 14 e to the 2u squared sine and cosine, and we have 14 e to the 2u quantity squared sine and cosine again. So it looks like this is just going to cancel everything. It's going to end up being 0. Wow. If that was the case, that means the partial of z with respect to u is equal to 0. That means the partial, or that means the original function f, when you put x of uv in and y of uv, must have been just a function of v alone and not u, because with respect to u, this turned out to be 0. So I would encourage you to check this out by putting in the value or the function x of uv and y of uv into the original f function and see how that will turn out. Okay. All right, let's go on to our next partial derivative. That is the partial derivative of z with respect to v. And the partial derivative of z with respect to v is the same, almost the same, except the paths will go down to v instead of u. Okay, so let's set up our formula for that. dz dv will be the partial of f with respect to x times the partial of x with respect to v plus the partial of f with respect to y times the partial of y with respect to v. We have these partial derivatives already figured out. We can recopy everything over, but I think I'm going to steal this portion as 7y, and our big denominator is the same. So negative 7x is over here with the same big denominator. So the only thing that I would probably want to change is these two terms here. So let me write this out first, and we'll start off with the e to the 2u cosine 3v minus 3e to the 2u sine 3v quantity squared in the denominator. And then I'll write my 7y, so 7e to the 2u sine 3v, and then the negative 7x e to the 2u cosine 3v. And so I'm just taking a shortcut here because it's essentially the same as the first term, except these things will change. And so I've written essentially what we have here and put it into one fraction. And so I just need to fill in the blanks for these things. So the x, the partial of x with respect to v, and the partial of y. This is a partial of y with respect to v. All right, so let's drop those in. This is going to be a negative 3e to the 2u sine v, and then this is going to be positive 3 e to the 2u cosine v. All right, let's see if we can simplify things a little bit. I think with this, I'm going to see if I can grab an e to the 2u squared, and also this is negative 21, negative 21, so I can take out a negative 21 from both of them. E to the 2u quantity squared, and then I would have left here is a sine squared 3v. There should be 3's there. So that's going to be a sine squared 3v, and then the negative went away, and the 21e to the 2u squared went away, so I have a positive cosine squared 3v since there's two of them, and that would just turn out to be 1. Meanwhile, the denominator, I can FOIL this out, but I can also just factor out an e to the 2u quantity squared, and then I have a cosine 3v minus 3 sine 3v. I suppose I can FOIL that out, but I don't think that's going to get me anywhere since I have an extra factor of 3 for the sine. So we got some things that can cancel. We got the exponential functions cancel. And notice that this is now just a function of v, not u. So that's the hint from the first derivative that we took. And this thing is equal to 1. And what we have left is not 0, but considerably simpler. We have a constant negative 21 on the numerator, and then we have this cosine 3v minus 3 sine 3v quantity squared in the denominator. Okay, that is your derivative of f with respect to v. And those are our derivatives, and I think we're done with this problem. All right, I hope that helps.